color is a little bit different with light than how you learned it in primary school and in art class. Primarily because when we talk about color with light, we're talking about additive color. When we're talking about additive color or combining different kinds of light, we have 3 different primary colors. For us, we have red as a primary color, we have blue, and we have green. These are our primary colors. I don't know why they are the primary colors, but this is how light addition works. So, when we combine red and green, we get yellow. Yellow is red plus green. When we combine red and blue, that's what we mix those two. So magenta is red plus blue. And when we mix blue and green, we get this color here called cyan. And a cyan, again, is going to be blue plus green. Now, when we mix all 3 colors, we get white light. And that is the mix of all colors. So, when we put red, green, and blue together, we get white. When we put red and blue together, we get magenta. If I were to put magenta and green together, well, that would give me white because I'd have all 3 colors. If I were to put yellow and cyan together, I'd get, well, yellow has red and green, cyan has blue and green, so I'd get a greenish white light. That's how additive color works. We combine them for more and more and more and more colors. So just as a note over here, we're going to say that magenta is equal to red plus blue, cyan is equal to blue plus green, and yellow is equal to red plus green. This is how additive color works. So this brings us to what happens when we see something. Well, let's say we have an object that is red. We have a red object. And let's say we shine white light. Oh, no, that's red light. Let's say we shine a white light onto that object. Well, white light has all the primary colors on it. So it's shining red light onto my object. It's shining blue light onto my object. And it's shining green light onto my object. What it means to be red is that only red light is reflected. That's what it means to be red. Red objects absorb green and blue and they reflect red. If we were to shine just green and blue light onto a red object, it would appear to be colorless or black. That's what lack of color is when we're adding light together. Same thing works for a cyan object. I'm sorry, that's magenta. Same thing works for a magenta object. Let's say I shine my white light onto my magenta object. That's not magenta. So we got red light, we got blue light, and we have green light shining onto my magenta object. In this case, the 2 colors that come off are blue and red. That's how we see colors. White light is absorbed by something, and only certain colors of light are reflected off, are given off. That's how we see color. A green object would absorb everything that's red and blue, and only green would be reflected from it. A yellow object absorbs blue and reflects everything else. A white object would be reflecting all kinds of light. But we would see these things coming off of it. That's how we would perceive color.